Hey everybody, today what you see on the screen, we have Unit 1, Question 1. Vector A and Vector B are unit vectors that make an angle of 52 degrees with each other. Calculate 3 Vector A minus 10 Vector B. I will be referring to them as Vector A and Vector B, even though I know they are unit vectors, because I will be saying them a lot throughout the video. So I hope that is fine. Right. Okay. So I've shrunken down the problem, so I have more room to work. So they're both unit vectors, which means they have a magnitude of 1. And then I'll draw one vector, and then the other vector will have an angle of 52 degrees relative to the other angle, regardless of which way I position them. Regardless of which way I position the first one, but I will choose to position my first one horizontally to make it a little bit easier. Actually, that's too long. I'm gonna draw vector B as my horizontal vector, and then after that, let's go up. So this will be vector A, and they are separated by 52 degrees. That looks like a 6. Hang on a second. Alright. So these are scalar multiples. This 3 times vector A will be 3 times, will have a magnitude that is 3 times larger than the original vector A. And so the 3 times 1 is 1. So this will have a magnitude of 3. The other one will have a magnitude of 10. I'm going to rewrite this as 3 times vector A add 3 vector A plus the opposite of 10 vector B. Sorry. So I'm going to draw on my vector A, my 3 vector A right here. And I will also put on, that's long enough, right? No, that's not enough room. I'm going to move that over. Okay, and then I will draw on my vector B, which will have a magnitude that is 10 times longer than the other one. That looks parallel enough. But instead of going this way, which would be positive vector 10 vector B, I'm going to put it in this direction, which is the opposite direction, because it is the opposite of vector B. Opposite direction, rather. So this is the opposite of 10 vector B, and this is 3 vector A. So I'm not yet able to add my vectors yet, because they are not positioned head to tail. Right now they're positioned tail to tail, and I can't just go like that and add it right now. I will need to move one of my vectors, and when I choose a vector to move, actually, sorry, I forgot to put an angle here. This is an angle 52 degrees, which would mean, well, I wouldn't need to calculate this, but I'm going to put that on there anyway. That would be a 128 degree angle. I didn't need to solve for that though, but that'll help my explanation. So going back to my point about adding vectors, I will need to move one of the vectors, and when I pick one to move, I will be picking the shorter one, which will be 3 vector A. I'm doing this because this will help make sure that my sine law solution will be the correct solution, because sine can be positive and still have 2 answers, and it will always give me this answer in quadrant 1 as opposed to quadrant 2. So I don't want to accidentally find this when I want to find this. So I'm going off on a sine law tangent, but the point is, after you use cosine law, which I will shortly, and you use sine law after cosine law, you will need to, it is the best practice to use the to find the smallest angle first, so that you do not find the wrong angle. So I will move 3 vector A and arrange it head to tail with negative 10 vector b, and that goes here. My hand's there, I can't see. Okay, that's about the same length. Obviously, this is 52 degrees away from vector b. Notice that there is a parallel line theorem C pattern there. Even though I didn't need to use it, I'm showing it here. Obviously, 180 minus 52 is 128, and 180 minus 128 over here will give me 52 degrees there. So now that I have the magnitudes of these two vectors, so I have 3 vector A here, I'm now able to draw on my resultant vector. So that goes here, if that line tool works. This is my resultant vector. I will call it R. And now I notice that I can use cosine law because I have a side, an angle, and a side. I'm going to erase that so you can still see my diagram. So when I have side, angle, side, I am able to use my cosine law. So I'm going to isolate my cosine law for the magnitude of R, my resultant vector, which will be, the magnitude of R will be equal to the square root of, the magnitude of one side plus the magnitude of the other side minus 2 times, oh, oops, I forgot to say that these are squared. Actually, I'll start that over again. We have magnitude of one side squared plus the magnitude of the other vector squared. And we're going to subtract 2 times the magnitude of this one. Let's not use that. So we have 10, and the other one is 3. And we're going to multiply it by the cosine of 52 degrees. That looks, sorry, my 5s look like 6s. Okay, and we're going to extend that, so that looks, oops. That's good enough. Okay, so now we're going to try to find our exact value for the magnitude of the resultant. So we have 10 squared plus, oh wait, before that, I noticed that when I calculated that, I used a positive value, even though it was negative 10, because when we use cos law or cosine law, we are inputting the length of sides in a triangle, which are the same as magnitudes, and magnitudes do not have signs. So that is why we are not putting signs into our cosine law. This will give me an exact answer. So 10 squared plus 3 squared is 109. 2 times 3 times 10 is 60. So minus 60 cosine of 52 degrees. That's too long now. Whatever. So that will give me an approximate value on my calculator. Hang on a second. Of 8.4888. That rounds up to 8.49 when we are going to 2 decimal places. Then the units were not specified, so I'm going to put units on just to be safe. So now we are going to find, so we're only halfway done. Notice that in the question, it did not have magnitude bars on it. If it did, we would be done, but it did not. We are finding the entire value of a vector, which means we need 2 numbers. We need a magnitude and a direction. So we have angle theta right here, which I've just indicated there. Let's do it in yellow, I guess. Okay, so I notice that now I'm given a side angle combo. I have an angle and an opposing side, and then another angle and an opposing side, and only one of those is unknown because I know the values of these 2 magnitudes, because I just calculated it here, and I know one of the angles, so now I'm able to find this angle. So when I write out my sine law, I'm going to put my unknown value at the top so I can isolate it faster. So that the opposing angle, the opposing magnitude of that angle is 3, and the other one is 52 degrees over the magnitude of our resultant vector, which we found to be 8.49 units. We need to isolate for sine theta to be able to use the inverse of sine theta. So we have sine theta is equal to 3 sine 52 degrees over, all over 8.49, sorry. So now we can use our inverse sine function on our calculator to find the approximate angle. This gives me, my calculator gives me 16.17 or 16.17. That rounds down because we're going to the nearest angle, so that rounds down to 16 degrees. And that is, we have to indicate from which vector this is from. So I drew my theta. I'm going to erase all of this. Hopefully I don't erase my diagram. Okay, so this angle is between vector B and my resultant. So this angle here is with relation to vector B. So I need to write a final statement, or I can circle my answers, but I'll write one anyway. Alright, so therefore, what's this expression again? 3 vector A minus 10 vector B has a magnitude of 8.49 units at, let's see if I can fit it on the screen, that looks like a B, at an angle of 16, oops, okay, that's not fitting my screen, 16 degrees, I don't know where to put 16 degrees with relation to vector B. That is my full solution to Unit 1, Question 1. Have a great day. Thank you for watching.